Ever wondered what really happens when you turn the key in your car? Let's explore every system, step by step, from ignition to motion. A modern car contains over 10 interconnected systems, all orchestrated by the ECU, the engine control unit. We will trace the journey from key turn, to fuel flowing, to spark firing, to wheels turning. The 12-volt battery is the source of all electrical energy. Turning the key has 3 positions. ACC powers the radio and wakes the ECU. ON activates the fuel pump and sensors. Start sends high current to the starter relay, which cranks the engine to life. When the key reaches ON, the in-tank electric fuel pump activates instantly, pressurizing the system to about 4 bar before the engine even cranks. Fuel flows through the filter, into the pressurized fuel rail, and out through 4 fuel injectors. Turning the key to start sends a small signal to the solenoid, which closes a heavy contact, pushing 200 amps from the battery to the starter motor. The pinion gear extends and meshes with the flywheel, spinning the engine until combustion takes over. The ECU sends low-voltage trigger signals to the coil pack. Each coil stores energy in its magnetic field, then releases it as a 35,000-volt pulse through the high-tension lead to the spark plug. The spark jumps the gap and ignites the compressed air-fuel mixture. Now the 4-stroke cycle. Intake, piston moves down, intake valve opens, air and fuel enter. Compression, both valves close, the piston rises, compressing the mixture 10:1. Power, the spark fires, the explosion forces the piston down, generating torque. Exhaust, the exhaust valve opens, burnt gases are expelled. A turbocharger is an exhaust-driven air pump. Hot exhaust gases spin the turbine wheel at up to 200,000 RPM. A shaft connects it to the compressor wheel, which forces more air into the engine. The intercooler chills this air, the wastegate caps boost pressure, and the blow-off valve protects the compressor. The ECU read sensor inputs thousands of times per second and calculates optimal actuator outputs. It controls injection pulse width, ignition timing, idle speed, valve timing, and the cooling fan. Every decision uses lookup tables plus real-time feedback from the oxygen and NOx sensors. The engine produces torque at the crankshaft. The torque converter or clutch connects this to the gearbox. Lower gears multiply torque for acceleration. Higher gears reduce RPM for cruising. Power exits through the driveshaft to the differential, which splits torque between the 2 driven wheels. The air conditioner uses the vapor compression refrigeration cycle. The compressor pressurizes refrigerant gas. The condenser at the front radiates heat outside. The expansion valve drops pressure. The evaporator inside the cabin absorbs heat, chilling the cabin air you feel. The brake pedal pushes a piston in the master cylinder, pressurizing brake fluid to about 100 bar. The ABS module sits between the master cylinder and each caliper. During a panic stop, ABS pulses solenoid valves at 15 Hz to prevent wheel lockup, maintaining steering control. Once the engine runs, the alternator takes over from the battery. The serpentine belt spins the alternator rotor at 3 times engine RPM, generating AC current. An internal rectifier converts it to DC. A voltage regulator clamps output to 14.4 volts, charging the battery and powering all accessories. Without cooling, engine temperatures would reach 2000 degrees Celsius and destroy the engine in minutes. The water pump circulates coolant through the engine's water jacket. The thermostat opens at 87 degrees, sending hot coolant into the radiator where it sheds heat to the air. Every system runs simultaneously, orchestrated by the ECU battery, starter, fuel pump, ignition, 4-stroke cycle, cooling, alternator, transmission, brakes, all working together, thousands of times per minute. That is how your car works. Thanks for watching. If you enjoyed this breakdown, subscribe for more engineering explainers, and we'll see you in the next one.